All right, so I'm seeing 7 o'clock, so we're actually going to get going here. So first off, hi, my name's Bill Leatham. I am one of the meteorologists at the National Weather Service in Norton, and with me tonight is my cohort and one of our lead forecasters, Kevin Kadima. We're going to go over the winter storm that impacted our region on the 13th to the 14th. But first, a couple bookkeeping items, just as a heads up. We routinely do some webinars on event reviews, and then also a little bit of meteorology and weather 101, or in this case, you can kind of see here on our webpage, Weather Models 202. But you want to frequently check our webpage at weather.gov/BOX. And at the top of the page, usually there'll be a link to our latest webinars, and that'll have a list of some of the different things that we'll be talking about in the coming days. And as you can see, we do have a couple of things coming up here in the early to middle parts of March. And I'm sure with this event coming up, we'll probably have an event review down the line with this event that's going to impact our region tomorrow. But with that, we're going to get going about this event review coming up. And then also for folks that are interested about the storm that's going to impact us tomorrow, we're going to do a real brief little briefing about what we're anticipating to happen across southern New England. All right. So with that, we're going to get going here with the slideshow. Make sure, Kevin, you can see that screen.
Yes, I can.
Okay. So again, like my name's Bill Leatham. I'm one of the meteorologists at the National Weather Service here. You can ask us any questions. We'll try to get to them at the end. We'll try to get through as many as we can. But I know Kevin has to be in the office for this storm tomorrow, so we won't be able to stay on here too long. So first, getting into a little reminder for folks if they don't remember. So what happened with this system? So here's just a look at the observed snowfall map across southern New England. You could see, we've got a pretty widespread 7 to roughly 10 inches of snow across Rhode Island and into southeast Massachusetts, and lesser amounts as you're getting into Connecticut and also especially like western and even central parts of Massachusetts. So there's a pretty good snowfall gradient across central parts of Massachusetts and even getting a little bit further west. And so one other thing, and we'll talk about it a little later in the presentation, that's really important when it comes to snowfall forecasting. There's a lot of different things, ingredients that come together when determining a snowfall amount. But one of the more important things in this specific instance was the snow to liquid ratios. And here's just a plot across southern New England of the different snowfall to liquid ratios across the region. And you can see on the map here, there's a lot of places had snowfall to liquid ratios of roughly getting up to 20 to 1, 15 to 20 to 1. Although there are some data points in here that are a bit lower than probably what was actually observed. And then just a quick little loop of the radar across the region. The one big thing to kind of point out here on the map is, and you'll see when the loop goes through here again, you can kind of see these bands of heavier snowfall across the region. The snow's starting to spread in early on the 13th. And you could see this band of heavy snowfall over the region, and then gradually, things transition. That snow band moves off. However, we have another snowfall band that sets up over Rhode Island and into southeast Massachusetts, and then eventually, once we get into February 14th, and you'll see here in a second, another band developing. And then eventually that band is going to move offshore. But you can kind of see here again through the loop of where we had some persistent heavy snowfall, but eventually it moved offshore as time went on. But with this, I'm actually going to pass the line to Kevin, who's going to go over a little more about the model information, the stuff that we're looking at when we're trying to produce our forecasts. So with that, I'll pass the line to you, Kevin.
All right, good evening, everyone. My name is Kevin Kadima. I'm one of the forecasters at the Norton office. So for the first graphic here, this is the GFS forecast, a 36 to 48 hour forecast of the 500 millibar heights and vorticity. And what you can see here, we had a pretty amplified mid-level trough that moved in from the Great Lakes. You can see it at the image on the left. We had it was a fairly dynamic system aloft. It was still positively tilted, but as it shifted east, it went to kind of a neutral configuration, and it was actually trying to acquire some negative tilt to it. So certainly it was a fairly it was an Arctic shortwave, and it was a fairly strong Arctic shortwave. So the next chart is the 700 millibar heights and vorticity. And you had some depth to this system. You still had a pretty good shortwave at 700 millibars. This was at 12Z Monday, so it's still at that time. A lot of the snow was starting to taper off. But out ahead of that system, we had some decent vorticity advection in the mid levels, which helped to contribute to the snowfall. So here we're looking at kind of a spaghetti chart. This is the 500 millibar, 516, 522, and 528 height lines that are valid on February 14th at 12Z or 7 a.m. So the thicker black line is the actual wrap analysis at 12Z Monday the 14th, and the various colored lines are the 36 to 60 hour GFS and Namm Forecast valid at that same time at 7 a.m. So what we can glean from this is that 36 to 60 hours out, there was a fair amount of spread in the guidance compared to what actually verified, and that kind of tells us that there's uncertainty. The models certainly were struggling with the amplitude, the depth, the intensity of this this mid-level trough, and whether it was going to become negatively tilted, and certainly that had some impact on some of the forecasts, out to day 2, maybe day 3. So here we're looking at this is the snowfall total snowfall plumes from the Trough model, the short range ensemble forecast system. This is valid for North Smithfield, Rhode Island, which was one of the locations in the maximum snowfall. It received almost 9 or 10 inches of snow. So each of the lines represent one of the ensemble members from the Trough. And so on the upper left, this is the forecast, the Saturday forecast from 3Z, the 3Z model. The lower left is the 9Z model. The upper right is the 15Z Saturday run, and the lower right is the 21Z Saturday run. So each of these lines, as I mentioned, represent an actual snowfall forecast. Now the star represents the 5-inch line here. So what we were trying to show here is that all these forecasts, 4 model runs on Saturday, the large majority of them were all under 5 inches. There were a few members, you can see at the 3Z run, a few members that actually were up near a foot. But if you go look at 9Zs, pretty much only 1 member above 5 inches, the 15Z only about 2 or 3 above 5 inches, and even at 21Z, maybe a handful above 5 inches. So majority below 5 inches. The solid black line represents the mean of all the ensemble members. This is a 21-member ensemble, and in all of these runs, the mean was around 2.5 to 3 inches. So, from the Trough, you would, if you're looking at this, you might go with a forecast of say 3 to 6 inches of snow, which obviously was certainly well underdone for the Trough model. But the important thing to point out here is that it does use a 10-to-1 ratio, and that's an important factor here. So here's the our national blend of models. This is like a 100-member ensemble. It uses global guidance and its ensemble members, and it uses high-res model guidance and its ensemble members. So it's almost a pretty robust ensemble system. You can see here that the forecast was actually from the NBM was actually pretty good for Plymouth County. It did quite well. I mean, Plymouth County had 8-9 inches of snow, and certainly it hit it right on the mark here. It was certainly overdone for the Cape and Islands. Cape and Islands saw certainly less than 6 inches, but it was very much underdone for the max area across Rhode Island and adjacent areas of central Massachusetts and southeast Massachusetts. So here is our HREF, high resolution ensemble forecast system. It's a 10-member ensemble system. This is the 0Z Sunday, so the Saturday night model run. We're looking at 24-hour mean snowfall of the 10 members. So you can see here, this is forecasting basically a 4 to 6 inch snowfall for a good part of Rhode Island and southeast Massachusetts, but it did do a pretty good job across Plymouth County, showing certainly a widespread 6 to 8 with some localized amounts of 8 to 10. So really good forecast for Plymouth County, certainly overdone for the Cape, but definitely underdone for Rhode Island and eastern Massachusetts. And I like to point out here that the HREF does not use a 10-to-1 ratio. It actually uses the snow liquid ratio from the Weather Prediction Center, WPC. So it's not a static 10-to-1. It uses some science, and based on what the WPC forecast is for snow ratio. So the next chart here is just the probabilities of 4 and 8 inches from the same run, the 0Z run. So kind of showing the same idea. You max probabilities of greater than 4 inches across Plymouth County, with moderate probabilities across Rhode Island and southeast Massachusetts. But notice that as you go into northern Rhode Island, central Mass, the probabilities of greater than 4 are only like 40 to maybe 60%. So pretty low. And then you're looking at probabilities of 8. The only probs you see are across Plymouth County. We have moderate probabilities, 40 to 60%, but basically 0% probability of greater than 8. So definitely a pretty incorrect forecast for that Saturday night run. And now the next chart is we're looking at the 24-hour ensemble max snowfall ending 12Z Monday. So it's taking all 10 members and looking at the maximum snowfall. So in this case, if you took the ensemble max, which is like a worst case scenario, it did a pretty reasonable job forecasting 6 to 8 inches across Rhode Island, central southeast Massachusetts, and up to 10 inches in Plymouth County. But again, this is one ensemble member. It's taken the max, and if you routinely went with a worst case scenario, you're going to be forecasting overdoing the forecast, a lot more times than not. However, this does represent a realistic worst case scenario. If everything came together, this is kind of showing you the max potential. And in this particular event, we realized that max potential, despite the fact that we didn't really have any period of heavy snow. It was more a result of a long duration snowfall. We snowed lightly for basically 24 hours with temperatures in the 20s, and that certainly contributed to the accumulations. But as we'll see here later, the snow ratios were the big factor. And so this is the Namm forecast. This is the 18Z Saturday run. That's just showing the aerial depiction of the snowfall at the 0Z Monday, which is 7 p.m. Sunday night, and then 6Z Monday, which is 1 a.m. in the morning on Monday. So overall, the Namm did a pretty good job showing the aerial coverage of snowfall, during the evening Sunday and into the overnight, showing that snowfall gradually, shifting into Rhode Island and southeast Massachusetts as we went through the overnight period. But the big question is going to be the snowfall amounts, as we'll get here soon. So here we're looking at a comparison of the observed 24-hour precip ending 12Z Monday, which is Monday morning. Now, the upper left is just a plot of various CoCoRa stations of actual liquid equivalent precipitation, and then on the right, this is the Namm forecast. This is the actual 18Z Saturday run forecast. So what you can see here is actually the Namm did a really good job with the actual QPF amounts, the precipitation amounts for this event. It captured the heavier precip across Plymouth County, where we're seeing 0.72, 0.885. The model's forecasting 1/2 to 3/4 of an inch, pretty good forecast. You get back across Rhode Island, it's showing around 0.4, which is pretty close to what fell, maybe a little underdone in some locations. We're seeing almost 0.4 out across Southeast Massachusetts, which is really close to reality, and even across Central Mass, around 1/4 of an inch. And you look at the amounts here, anywhere from a 1/4 to 1/3. So 42-hour forecast from the Namm, these precipitation amounts are actually quite good. Again, the issue was with the snow liquid ratio. Certainly, if you use the 10-to-1 ratio, that was definitely way too low. The next graphic here is the actual snowfall using the Kuchera method. Now, the Kuchera sometimes can be right for the wrong reasons, because the Kuchera is not looking at anything that's going on within the cloud where the ice crystals are being generated. That's the biggest factor to snow liquid ratios, the cloud microphysics, the thermodynamics, what's going on in the cloud where those ice crystals are being generated. In this case, the Kuchera method uses the maximum temperature in the lowest layers below 700 millibars. So the colder your temps are in the at 925, 850, 700 millibars, the higher the ratios are going to be. In this particular case, it basically showed a widespread 3 to 6 inch snowfall across the region, which is basically maybe a little higher than 10-to-1. And the reason for that is the maximum temperatures in those lowest layers between 925 and 700 millibars, weren't really that cold. They were like -2, -3. So you basically getting like a 10 to maybe 12, 13-to-1 ratio. Again, it's not accounting for the cloud microphysics and what's going on within that snow growth region. That's the most important factor. So this is the same graphic as before, except it's actually a 24-hour forecast from the Namm ending 12Z. Again, it did pretty well in Plymouth County, but it actually kind of deteriorated in time. We're not seeing any amounts around 0.4 like we were seeing in the 18Z Saturday run. So, I mean, overall, it was okay, but it was actually a little worse than the 18Z Saturday run. And then just for comparison, we used the GFS to compare that to the Namm. This is a 24-hour forecast. This is the actual 12Z Sunday run. So again, it's a little lower resolution model, so it's more broad. It kind of irons out some of the mesoscale details that the Namm might show, but it showed 3 to 4/10 of an inch across Rhode Island and Southeast Massachusetts, which was okay, not too bad. It did not really pick up on the heavier QPF across Plymouth County, and certainly didn't pick up on the heavier QPF across portions of Worcester County. And so here is the same kind of deal with the CocoRoss precipitation amounts on the left, and this was the Weather Service forecast that we issued Saturday night. So our precipitation forecast was actually pretty good. We showed the 1/2 inch to 3/4 across Plymouth County. It was a little overdone in the Cape, but for the most part, we had 1/4 to 1/2 inch across Central Mass, Eastern Connecticut into Rhode Island and Southeast Massachusetts. So overall, a pretty good forecast. And Bill, I just actually lost my connection.
Oh, okay. I can always take over if you need me to.
No, let me go ahead and just try to log back in here. Give me a second.
What's interesting is I can still hear you, but no worries.
Yeah. You know what? I can go ahead. I can still speak to the slides. We're on
the Frontogenesis on the Namm with the 3
okay, the Namm. Okay, yeah. So right. So this is the Jersey Monday Namm. This is just a 3-hour forecast of 850 millibar Frontogenesis at 3Z. And you can see the frontogenesis. There are two main terms in frontogenesis. There's a deformation term and there's a divergence convergence term. In this case, convergence was driving the frontogenesis because you can see here, you got some southeast winds across southeast Mass, Cape Cod, and you go further in Western Mass, it's like west-northwest winds. So certainly convergence is the driving factor to this this frontogenesis, showing some decent frontogenesis across central Mass where some decent snowfall was falling at that time. And so now the next graphic is looking at a forecast sounding valid at the same time at 3Z for a location on the Rhode Island Central Mass border. So what we can see here is the dendritic growth zone, which is where your best ice crystal generation occurs, is about 800 to 600 millibars. And you can kind of see here by the red and green lines, they're very close together. It's showing you pretty much that it's saturated. So you have a saturated dendritic growth zone. And also note the best omega was occurring right within that, that dendritic growth zone. So when you have your, granted the omega wasn't very strong, and certainly that was an indication of the fact that the snow was mostly light, but the fact that you had modest, at least modest omega right within that dendritic growth zone, and also it being saturated, that promotes higher snow liquid ratios due to efficient snowflake production. It's all about what's going on in the cloud where the ice crystals are being generated, and typically they're generated in that -12 to -18 Celsius layer, which is indicated by those horizontal black lines. So you had saturation in that growth zone and decent omega. So the next slide is showing you the same deal, 850 millibar frontogenesis at midnight. So again, it's largely driven by convergence, and that's kind of shifted across Rhode Island and Southeast Massachusetts at that time. So the next slide is showing you the Namm sounding at that very same time. Now note that dendritic growth zone has deepened. It's now between 900 and 650 millibars. It's still saturated, and again, the best omega is right within that that zone. So again, that's really contributing to very efficient snowfall production. This is a recipe for much higher than normal snow liquid ratios, and certainly supportive of getting, say, 15 to 21 ratios, certainly with temperatures in the 20s. Now the next slide is the 2 hours later at 7Z. Again, it's very similar in depth of that dendritic growth zone between 900 and 650 millibars. And again, not strong omega, but modest omega right within that region. So you had that persistent, you had a saturated, deep dendritic growth zone with modest upward vertical motion within that zone that was conducive to producing those higher snow liquid ratios. And then the next slide is just showing you the frontogenesis at 8Z, kind of showing how it's starting to shift to Southeast Massachusetts as the system is starting to pull away. And then the next slide at 10Z, now it's confined to the Cape and Islands. And certainly a few hours after that, the snow is starting to move offshore, except for some lingering ocean effects snow showers that lingered into that morning. So with that, I will turn it back over to Bill, and he will discuss some of our forecasts and messaging and mesoanalysis.
All right, thank you very much, Kevin. So just leading up to the event, I mean, you kind of saw some of the different forecast models. We kind of try to take in as much as we can. There's just a fire hose of information at this like with so many different pieces of guidance to look at. So here's a look at our first snowfall forecast that we put out. This is on the 12th, and this was issued late Saturday, again, late Saturday into early Monday. And this is issued Saturday morning, but you can see in the snowfall amounts initially, really only expecting like a 1 to 3 inches of snowfall from like Southeast Massachusetts into the Cape Cod and the islands, with the highest totals over the Cape and Islands, with lesser amounts as you're getting further further inland, and you can kind of like from some of the stuff Kevin has shown, you can kind of see, potentially why that was. However, as time goes on, you can see here that our snowfall totals increased, and on the left-hand side is our actual forecast that we issued. I actually think it was Kevin that issued this on Saturday afternoon. But you can see the snowfall totals have increased across the region, with a more widespread, roughly 3 to 6 inches across southeast Massachusetts into Cape Cod and the islands, with lesser totals as you're getting further inland. And because of that increased snowfall amount, we were starting to get concerned with those snowfall totals, and plus this is also right around when the big football game was going on. We hoisted a winter weather advisory across Plymouth County, Cape Cod, and the islands. As you know, with this amount of snow over, it was over a very prolonged period of time. But with this amount of snow, it can cause some travel issues. So that's why we had posted the winter weather advisory. So now, getting real, pretty much starting to get into the event. This is the midnight shifts forecast. Uh, and you can see here the snowfall amounts have continued to increase. Again, as Kevin had kind of mentioned, he showed our liquid precipitation forecast, but you can see across, especially Plymouth County. We've got the 6 to 8 inch snowfall amounts, which was pretty pretty excellent forecasts for that area. But you can see here, as time's gone on, the snowfall amounts are increasing as we get into the event, and because those snowfall amounts increased across the region, you can see that we expanded the winter weather advisory. Again, usually we have that threshold of roughly like 3 inches, where it will cause some issues on the roadways potentially if they're untreated. But you can see here too. The other thing too is like another thing we take into account is the time of year and what things are going on. And given the fact that there's usually a lot of people that travel around this time of year, you can see we expanded that winter weather advisory with those increased snowfall amounts across a good portion of the South Coast. And then again, you can see I'm going to switch between the midnight shift forecast, and then here's the update by mid-morning. You can see the snowfall amounts continue to increase, especially getting into central Massachusetts, and also even into towards like the Boston area. And you can see because of that, the winter weather advisory again has been expanded because of that increased snowfall amount. The one thing with this situation was that the snowfall was over such a long period, as Kevin had kind of alluded to. But again, definitely going to cause some slippery roads and travel impacts with the things going on, that day and that evening. So to kind of dial we actually tend to do these event reviews not only like for everyone that's joined the webinar here, but also like internally, because it helps us kind of gauge like where we went wrong and where we could do better in the future. But one of the things we have to look at when we're doing this too is to kind of not only look at the forecast models, but obviously look at what happened and dive deeper into the data of when things actually, or what things actually happened. And one of the things we do look at are meso analysis. I don't know if folks are aware of it, but the Storm Prediction Center has a really great like real time, as close to reality as you can with the model data of what's going on in the environment. And that's called the SPC meso analysis. So we're going to start looking at the data that we would typically look at when we're looking at the forecast, but also even when an event's going on. And we're starting from like the higher levels of the atmosphere here. So this is a 300 millibar analysis on 7 p.m. Sunday. You can see that we have a really impressive upper level jet of 160 knots moving across the region. And then you can see with these magenta lines, those are indicating areas of good divergence aloft, which tends to mean that there's going to be more lift across the region. You can see there's a pretty solid amount of lift off off the coastline, but you can see that it's starting to get into into parts of the south coast. And because when you have this kind of lift, it's conducive for weather to happen, assuming you've got moisture and other things. But yeah, so going a little bit further down in the atmosphere at 500 millibars again at the same time, 7 p.m. Sunday, we've got an amplified trough, which is what we're talking about across the central and into the eastern parts of the Great Lakes. As Kevin had kind of shown earlier when we were looking at the forecast models. And because of that, on the eastern side of it, just the way, and you may learn more about this in Weather Models 202, or if we've already talked about it in Weather Models 101, that implies that there is lift ahead of the trough, which would be over, the eastern Great Lakes and into our neck of the woods in southern New England. Going a little bit further down in the atmosphere, this is 8 p.m. on Sunday, so an hour, a little bit later. We've got southwest flow aloft, which is indicated by these black wind barbs in the mid levels in it, and then the green that is shaded is basically showing where it's saturated, or if you're looking kind of back or looking back at like the model forecast soundings that Kevin was showing, that's where that green and red line is basically right together, where the temperature and dew point is like right on top of each other. And you can see across much of southern New England, going from roughly central Massachusetts into Connecticut, eastward, you can see that we're pretty saturated across the region. So going down a little further in the atmosphere, this is 1 a.m. Monday, so we are going a little later in time. These blue and red lines are the temperature values, whereas the black is the heights, and then the little cyan not cyan, sorry. I'm trying to think of brownish are the wind barbs at this level, and you could see across southern New England by these wind barbs that there is convergence where you've got westerly winds across Connecticut and into central Massachusetts. But when you're starting to get into Rhode Island and southeast Massachusetts, those wind barbs are coming together, showing that there's some sort of convergent flow. And when you have this happen, that's implying that there's upward vertical motion. And I'm not going to go back to the radar loop, but this was also when we had precipitation falling across the region. But that's kind of one of the things that the upward vertical motion is indicative of, assuming you've got some sort of moisture within that column of air. Going a little bit further down in the atmosphere, this is 12 a.m. on Monday. You can see with how closely these temperature lines are together. There's a pretty strong, what we would say is a temperature gradient across southern New England. And then you can see a little bit of convergent flow across eastern Massachusetts. And this is more because of the wind shift that we have here versus like we saw with the 850 millibars, where your wind direction, one was westerly, one was easterly. It's a little more subtle here, where we've got just like a shift in the wind direction, showing that there's a little bit of convergent flow across the region. So now just looking at a time progression here as time is going on with the system that we're talking about. You've got this low well offshore of the mid-Atlantic on around 1 o'clock on Sunday. The low starts moving closer to southern New England by 7 p.m. On Sunday, and then as we get into to Monday morning, the low is lifting northeastward just offshore of Cape Cod and the islands. However, by these pressure, the way the pressure is analyzed here, there would be what we would call like an inverted trough punching or nudging into southern New England. And then you can still kind of see that feature even on 7 a.m. on Monday, with the low moving well offshore south of Nova Scotia. But by these pressure contours, you can see that we still got this like surface trough pushing into southern New England. And so as Kevin had kind of alluded to, one of the factors that we had with the band of snowfall, the thing we're usually looking at is called Frontogenesis. Um, uh, and you could see up in the higher levels, these areas that are colored and contoured are where we've got high values of frontogenesis. And you can see in the higher levels of the atmosphere at 700, right around 6 a.m. on Sunday, you can see that, it's over a good portion of southern New England and into portions of northern New England. And then once you get down a little later in time and a little lower in the atmosphere, and later on Sunday, the 850 millibar frontogenesis, you can see moving offshore of the mid-Atlantic and pushing into southern New England. And that's one of the other tricky things when it comes to snowfall forecasting, with finding out where these bands of potentially heavy snowfall are going to be. It's also figuring out which layer, where you've got these frontogenesis bands, where that band is going to develop. And sometimes that's something that's difficult to do leading up to, and more of like what we would call like a nowcasting situation, where like you kind of see it happening and you kind of react to what you're seeing on radar or what you're seeing in the analysis data. And so looking at the Storm Prediction Center, there's some layered frontogenesis. This is late on or really early on Monday morning, late Sunday night. And you could see in the 850 to 700 millibar layer that it's over Rhode Island or southern Connecticut into eastern Massachusetts. And then looking a little a little lower and also a little bit or lower in the atmosphere, across southern Connecticut, or a good portion of the south coast, where you can see that frontogenesis maximum. And then once you get a little bit lower in the atmosphere, you can see it kind of shifts again over eastern Massachusetts. But if I had the radar loop in here, you'd see too that typically with these frontogenesis bands, these bands of heavier snowfall bands, they tend to usually occur to the north or the northwest of the bands. And if I had a radar loop, you would see there would be some of those banded areas of heavy snowfall that we're usually looking at. Usually they're heavier, but as Kevin had kind of talked to, given the lift that we had, it was more of like a light to moderate snowfall over a long period of time, maybe heavy in some spots. And then moving into some other information that we look at as well. As Kevin had alluded to, the dendritic growth zone, which is that it's roughly minus 10 to minus 20 degrees Celsius. If you can have a saturated layer or saturated within that layer and a good amount of lift, that's where you get those really, really good snow to liquid ratios. And this is just showing here where you've got the green areas roughly where it's highly saturated. And as you look at these areas of purple in the contours, they're showing where there are higher amounts of lift within that layer. And it's roughly in these areas where you would expect there to be heavier or the potential for heavier snowfall, assuming you've got enough lift. And as you can see over time, this does a pretty good job. 7 a.m. Sunday, again, if we had a radar loop on this slide, it'd probably be easier to see. But you would see usually within this area, there's a band of heavier snowfall. And over time, you can see the shifts to the southeast before we eventually see that band that developed again over like Connecticut into central Massachusetts and Rhode Island. And then eventually, as time went on, it moved offshore into southeast Massachusetts, Cape Cod, and the islands as time goes on. But again, this is one of those areas that we look at, particularly where there's the risk for high snowfall ratios and usually pretty good snowfall amounts, assuming you've got enough lift within this layer. So just like to go over for this event overall, it was a really long duration snowfall that brought several inches of accumulation across the region. Again, the radar loop showed it, and Kevin had kind of talked about it as well. There's roughly 24 hours of light snowfall. We didn't really have any visibilities that drop below a mile, which is usually once you're starting to get below that 1 mile threshold, that's where you're getting into the heavier, moderate or heavier snowfall. As Kevin had alluded to with the spaghetti plot, the model initially struggled with the amplitude and strength of the Arctic shortwave. We did a really good job with the liquid precipitation amounts, but because of the snow to liquid ratios, they were unfortunately underdone. Other than, we did a really great job across like Plymouth County, but when you're looking at Rhode Island and into central Massachusetts, obviously, based on what fell, those snowfall amounts were too low. The initial burst of snow on Sunday was associated with that mid-level frontogenesis, where you tend to see those higher snow to liquid ratios, which in that case was roughly 15-1. And then once we got into the second half of the event, we had dynamic forcing from the shortwave, inverted trough, and then on top of that, some low-level forcing with that convergent flow that we were talking about a little earlier in the meso analysis. And with that, with the colder air coming in, that snow to liquid ratios went up from that 15-1 that we had earlier on Sunday to 20 to 25-1 once we got into the evening. And again, because we had the amount of lift or what we call omega within and that it was deepening within the saturated dendritic growth zone, it really helped enhance the snow to liquid ratios for this system. So really what it came down to, overall the forecast when it comes to precipitation and for parts of the region, the snowfall amounts were really good. But for other parts of the region, because of the snow to liquid ratios were too low, was why the snowfall amounts kind of underperformed. And I think with that, so the next section is actually going to be a weather briefing coming up for the storm tomorrow. But I think we'll take we'll take a brief couple questions about this event, and then we'll hop over into the weather briefing for the storm coming tomorrow. But we won't, like I said, we're not going to do it too long, just because Kevin is actually one of the people working the storm tomorrow. So we'll take a look at some questions here and try to answer what you got. All right. Can you see the questions at all, Kevin? So I'm gonna pull them up here.
Yeah, I can see a few of them here.
And I see you answered a couple of them
I did,
already.
but I don't see them. I'm only seeing like one at a time.
Okay, that's all right. I got them up here. So let's see here. I'm trying to see if there's any. I guess this is an interesting question. I'll throw it out. And either of us can speak up here. But the one we've got from Ethan, and thank you again for coming to the webinar, everyone. So does our office ever fall prey to recency bias? And his example is if a snowstorm occurred a few days after February 13th to 14th, and the setup was similar to the 13th to 14th one, do you lean towards forecasting higher snowfall totals compared to what actually happened on the 13th and 14th? I'll let Kevin hop in here in a second, but just at least speaking to myself, there's probably a little bit of that depending on who is working. I know Kevin and we were the folks that were working leading up to and into this event. So sometimes that'll happen, especially if you see a pattern that is very, very similar to what just happened. But the thing is we have different people working through different events because we have different shifts. So it ultimately kind of also depends on who's working and if they were the person that was quote unquote, burned by an event that had happened. But I'll let Kevin speak a little bit about it too, if he's got anything else to add.
Yeah, Bill, thanks. I would say, certainly that's human nature, but typically, we just try to follow the science of the event. And the thing about the atmosphere, no two storms are ever alike. The overall pattern, large scale pattern might be very similar, but there are always some wrinkles. There's different things going on in the mesoscale, the microscale. And so, we like to say past performance is no guarantee of future results, kind of like the stock market. It's the same thing with weather forecasting. Every event is different. There are always similarities. We look at analogs from previous events that kind of mirror a similar pattern. But in the end, you got to drill down into the details, and there are always wrinkles with these storms, and so it's important to look at all different aspects of it, because again, no two storms are going to be exactly alike.
All right, let's see. So another question here is, so when the model like the Namm performs well in this storm, do we tend to give it more credence in upcoming storms? And you may have actually kind of alluded to that, or not necessarily, a specific model, and like how you answered that last question. Whereas, there's no two storms are alike, where you got to really dive into the details. I mean, the thing is, we look at all as much model guidance data as we can when we're going into producing the forecast. I mean, I don't know if you've got anything else to add here, Kevin, but I mean, we even if we think the Namm is like just crazy, doesn't make any sense, we're still going to take that piece of data as into our forecast.
Yeah, I would agree with that. I mean, like I mentioned before, model can do really well on a particular event, and then the next event it doesn't do quite as well. So you really have to look at the totality of the guidance. It's important to look at the ensemble distribution to see where that model might lie within the whole distribution. There's a lot of stuff that goes into it, but certainly we take all the guidance and evaluate it and go forward based on what we think might be realistic or not realistic.
All right, next question is from Scott. Are there things that can be learned from the struggles regarding overperforming and underperforming with the storm?
Yeah, I mean, I can take that. Some storms overperform, some underperform. In this particular case, it was the snow liquid ratios, because if this was a summertime event and we were forecasting a quarter to a half inch of rain, that's essentially what fell. But unfortunately, it's not the summer, it's the winter, and when it's snow, obviously it's scrutinized a lot more. And basically, the biggest problem with this storm was the second half of the storm, which was the late afternoon through the Sunday night. The snow ratios during that part of the storm were actually 20 to as much as 25 to 1. So it's very, very rare that we're ever going to forecast, especially in southern New England, where climatology of snow liquid ratios are typically around 10 to 12 to 1. It's going to be very rare that we would ever forecast a 20 to 25 to 1. But in this case, that's what happened. And so the issue of this overperforming really came down to snow liquid ratios. They were not well forecast. I mean, we would have never forecast 25 to 1, but certainly we could have forecast, say, 15 to 20 to 1 and been maybe closer in the ballpark. But yeah, snow liquid ratios, we have a ways to go. There's a lot of science on that, and that's one of the areas that we really can make improvements in snowfall forecasting. It's a big factor in snowfall forecasting.
Yeah, and I'll just add like a real quick extra bit to that is at least coming from the data that we can look at even in the office, there's just not a whole lot of snow to liquid ratio guidance that's like available to look at, that goes into what is thrown into the forecast. So as Kevin has said, there's we've got a ways to go, at least on that respect to snowfall forecasting. So next question from Caleb, and this is the last one that we'll do at least for this section, and then we'll do a real quick briefing with this upcoming storm tomorrow or late tonight into tomorrow. So does the strong frontogenesis mean that with updrafts you will have really strong condensation? You know, I'll try to handle this one. I mean, because frontogenesis, it's basically where you've got good temperature advection, and then there is like convergence, or roughly right around that kind of area. You can have strong condensation, but you got to have the moisture available. I don't know if that really answers it, Kevin. I mean, you can, but there are instances where you have strong photogenesis and there's no moisture there, so you don't get any like heavy precipitation. It's all about really like, yeah, you can have strong frontogenesis because there's a good temperature, like temperature advection over an area where there's strong convergence, but uh, it doesn't necessarily mean that you're going to have like heavy precipitation. You got to also have the moisture available in that area, and that's not all of what Frontogenesis like goes towards.
Yeah, I mean, I would agree with that. Frontogenesis is basically a lifting mechanism. It's just one part of the equation when it comes to precipitation. It's an important one, but there are two others. Obviously, you got to have the moisture. You can have all the lift in the world. If you have no moisture, then you're not gonna condensate. And then the other factor is instability. Instability helps to enhance the response to that upward motion. So if you have a lot of moisture and a lot of lift, you're going to get precipitation, but you're going to get more intense precipitation if you have instability in addition to the moisture and lift, because you're going to get a greater response to that lift. So you're going to get an extra boost to that lift if compared to if that instability wasn't available. So in this particular storm, we didn't have any instability, and we didn't even have very strong lift. We had modest lift, but it was just duration dependent. It fell over a long period of time, and it was enhanced by the snow liquid ratios. But if you want to get a lot of heavy precipitation in a short period of time, you got to have moisture, you got to have lift, and you have to have instability. Those are the three biggest factors to get an intense precipitation.
All right, so that's actually all the questions we have, at least about the event. At this point, I guess we're gonna go over to the weather briefing for this upcoming storm.